Sodic clay soil disperses when it becomes wet. This dispersion can be seen when crumbs of sodic clay soil are put into a petri dish of water. The aggregates break down, that is, they slake, and the tiny clay particles then disperse into the water. This animation shows how this happens at a microscopic level. Clay particles are typically like platelets. These have negative charges on their faces, and sodium ions in solution are attracted to these negatively charged faces, and they form a cloud of sodium ions adsorbed to the negative charges. From a side view, we can see that the cloud of sodium ions is densest close to the negatively charged clay platelet. The cloud of ions is less dense with distance from the clay surface. This combination of charges, negatively charged sites on the clay surface, and the cloud of cations in the adjacent space, is called the double diffuse layer. Let's look now at what happens when two clay platelets come together. While the clay particles are widely separated, they do not affect each other's movement. But as they approach each other more closely, the clouds of cations on each side repel each other, and the clay platelets remain separated. This is what we mean by clay dispersion due to sodicity, the dispersion of clay platelets because of the adsorption of sodium ions onto clay particle surfaces. Let's look now at what happens when we substitute calcium ions for sodium ions in the double diffuse layer. Sodium ions are monovalent, and by this we mean that they have a single positive charge per atom. By contrast, calcium ions are divalent. They have two positive charges per atom. When divalent calcium ions come into contact with clay particles, they adsorb much more strongly to the negatively charged surfaces of the clay platelets, and the cloud of cations making up the diffuse double layer is far thinner. And when two clay platelets dominated by calcium ions approach each other, the tightly adsorbed clouds of calcium ions are not an impediment, and the clays can become joined together by weak forces called van der Waals forces. This clinging of the clay particles together is called flocculation.